In week 1 of our class, I talked about my role as a DBA. We're actually jumping now to chapter 16, which talks about the concepts of DBA. Here is a table from the text with desired DBA skills. You'll see in the left column are some managerial skills, which you'll pick up in many of your other classes, and technical skills. Our course has focused on those technical skills. Chapter 16 looks at 3 functions of a DBA: concurrency control, which we will talk about and understand a little bit when we're looking at transactions; security, which is what we're talking about today; and backup and recovery, like when you have a hurricane and you need to recover your database. Let's look at how the users can gain access to Microsoft SQL Server database. So we have our users, and our users are going to start the authentication process by using a login. That login could be Windows. Probably more likely it's going to be a SQL Server login. But if you're at work and at work you're on a Windows server, it could be the Windows login that authenticates you. Then once you're logged in, there's going to be a set of permissions. This is what do you have access to. So it can be the individual that has permissions, or a role can be assigned a set of permissions. Those set of permissions that user has will allow them to have access to certain objects, certain schema. I referred to it as sub-schema week 1. In addition, does that user have access to run DDL? A DDL would be statements that can modify the data, inserts, updates, and deletes. We'll be getting into DDL next week. And here is our SQL for creating a login. You use the keyword create login, make up a login name, and you must use with password and assign a password to it. This is the syntax. So this is showing me optionally I can add must change. So have you ever had a new account created and you had to change the password right away? This is how you would do that in Transact SQL. And there's some other optional expressions that you can add. And here's an example. We're creating a login for John Doe, and there's their password, but they must change it. And we're going to use this default database here. So when they log in, they're logging into the HCCDB. Now I want to add, depending on the permissions John Doe has, he may be able to change into a different database. We'll look at that in a second. Now, in addition to that login, the database has to have a database user. So even though you just created a login, you're not done yet. So you're going to use create user and make up a username for a certain login. And you're going to assign a certain default schema. These two are optional. So here we're creating a user, John Doe. Because we haven't used for a certain login, it's going to be assumed that the login is the same as the user. And here is an example now of creating a login for a Windows account. Here is an example now of creating a database user for a Windows account, assigning a default schema. So we saw we have a login and a user. Now we have to authorize. And this can be quite tedious, actually, overwhelming. What does John Doe? He's been authenticated. What am I going to allow him to access? Let me show you something. This is just some documentation from Microsoft on SQL Server, but I want you to notice that number right there. There can be over 2 billion objects in a SQL Server database. If your role was to take a new user and assign them permissions to objects in the database, how many objects and how many users? It can be overwhelming. You can spend all your time doing this if you do user to object. But of course, there's a simpler way to do this. Step 1 in making things simpler is for you to create roles. So roles are a collection of permissions. Oh, let's take HCC. As a teacher, I have a certain role. I'm allowed to update grades, for example. As a student, you have different roles than I do. So you might be put into the HCC database in a student role, I in a teacher role. So now, instead of going one by one, this individual has those objects, we're going this role has those objects, and you're assigning permissions to the role instead of the individual. Meanwhile, you also have to put the individual in the role. Roles provide a much more efficient, maintainable way to control user access to the database. New roles can be created as needed. The granularity can be increased or decreased as needed. That's one of the quote roles of the DBA, is to decide how finely you're going to assign those permissions. The main thing is, the real rule is minimize permissions. If you want to secure your data, you're going to give minimal access to only what is needed to get the job done. Okay, I told you if you log into a certain database, you can get into another database. Here's an example of what's called Transact SQL script. That's SQL Server script. And the first statement says to use, and that's the name of a database. If you want to run SQL, you can type use and a database name, followed by go. And go just means, okay, I want you to execute that command above. After that command is executed, the user is now in this database, and in that database, we're going to write that SQL statement that's going to create the role called student role. Part 2 of making this easier is schemas. Schemas can be used to achieve results similar to roles. Now, roles we're aggregating and assigning permissions to a group of users. Schemas is aggregating a collection of objects. A user could be assigned to a role, and then that role is assigned permissions to schema objects. So when they log in, when the user logs in, the only thing they're going to see are the objects they have permission to. They don't even know there's other tables. If it's your job to set this security up, it takes some analysis. It takes analysis of deciding what roles are needed and what objects those roles need, and minimizing those objects so that the job can be done, but yet we don't have people viewing things they should not be viewing, modifying things they should not be modifying. Here is an example maybe of some roles that might be assigned to a corporate database in accounting, customer service, marketing, etc. And in those roles, we're thinking, well, let's create a sub-schema. So anyone that is in HR can have access to this set of tables. And anyone in accounting, well, we have a different set of tables. Now, I got these from 2 different databases, but staff and employees are probably the same. Let's say they're the same. This is employees. HR might have permission to add records to employees, but the accounting sub-schema or the accountant role may not have that permission. Maybe they can select it, they can view it, they can't add records or delete employees. So not only must you decide what objects you're going to give to each role, you have to decide what that role is going to be allowed to do within those objects. So here we're looking again at the accounting subschema, and types of permissions that can be granted are select. That just means you get to view it, and that's it. Insert. That means you can add new records, or you can modify existing records, or delete records. I haven't added any constraints. Notice, typically delete's going to have the fewest permissions. Sometimes that permission to delete has to go up to management for that decision can be done. And here we have our different tables, our database objects that can be secured, permissions that the accounting subschema has. Here is the SQL syntax to create a schema. Create schema, the name, and then we have some optional phrases. We're going to keep it simple. Just do it, create schema accounting. Here, this statement is creating a schema marketing and saying, oh, marketing is going to have to have a contacts table. So they're creating the table at the same time as creating the schema. So you know how to create roles, you know how to create schemas. Let's assign permissions. Now notice the permissions are not create. Permissions are going to be grant, revoke, or deny. This slide shows the grant command. You're going to grant a permission on a certain schema, optionally a certain object. Optionally, you can actually go through the columns. 2, this is going to be a user or a role name. And this optional with grant option, if you add that, then you're going to give them permission to grant permission, which I would be very careful about doing that. And here we have a user, Susan Roberts, with select permission to invoice. Here we have the same user. Now she can also add records, update records, and delete records. Remember, insert, update, and delete we're going to call action queries because they can modify data. Here's another example, getting a little more granular. Instead of the whole vendors table, Tom, Aaron, and this Windows login are going to have only these fields that they can view, and that's it. The other fields, they can't see it. Let's say you want to issue the grant statement to a schema. Syntax changes a little bit for this. Notice this set of colons here. So grant permission, again, select, insert, update, or delete on schema, colon, and the name of your schema. 2, and this could be an individual or a role. So here, grant update on schema accounting to John Doe. Here's the SQL to create a role. Okay, it's pretty simple. Create role invoice. And now with that role created, grant insert update on invoices, that would be a table name, to invoice entry, that role. And grant insert update in invoice items, line items, to invoice entry. And now let's add some users to the role. So we're going to do alter role, invoice entry, add member, John Doe, add member, Susan Roberts. That would be the username. Putting it all together, let's create a role, sales report, and we're going to grant select on a schema called sales to sales report. So this very simple overview of security, because it gets way more complex than this, is you have grant, deny, revoke permissions in SQL, deny blocks access, and trumps all other access. For example, if a user is granted permission for invoices, and that same user then is also denied permission for that invoice, the denied is going to overrule. And revoke just undoes any permissions that's there. Types of permissions are select, insert, update, delete. Delete's not there. And also know what users are, roles are, objects are just tables and views, etc. in the database, and know what schemas are.